List comprehensions are a feature of functional programming languages such as Lisp, Haskell, or Camel, and a few others. Functional programming languages are languages that support a completely different style of programming, in which instead of giving the computer commands, you ask the computer to evaluate functions. And essentially, all programming is reduced to the evaluation of functions. Although they are experiencing a resurgence, these programming languages have never been too popular because while they simplify some complex tasks, they make some very easy tasks complicated, and therefore they are not very practical. However, some of their most successful features are seeping into other more traditional programming languages, and list comprehensions are just one such feature. Essentially, comprehensions are a very convenient way to build a list or starting from another list, or if you want, to process the elements of a list. Let's have a look at this example. Here we have the range function that creates a list with the elements from 1 to 6 minus 1, which is 5 included. And this list is displayed by this instruction, and then we construct another list which contains 3 times the value x for x that varies across list A. So in list A we have the elements 1, 2, 3, 4, 5. So 3 times x is going to be 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5. And this makes up list B. Actually, if you want to see the contents of the first list explicitly, it's probably better to add the list here, so that there we go. So these for and in are key parts of the syntax of the list comprehension. As you see, the comprehension is delimited by square brackets, just like a standard list. And for those of you who have heard about for loops, this for in is by no means a general purpose for loop. It's just something that's specific to comprehensions. It's similar to the syntax of the general for loop, but not quite. And we will see general purpose for loops in a later notebook. Now, comprehensions also allow us to use an if keyword to actually specify which elements we want to include. So for instance, suppose that we want to extract the even elements of this list A. Those are the elements that can be divided by 2. So we can say even equal x for x in A if x modulo 2 is 0, that is, if the number is even. And that will extract all the even numbers. Vice versa, you see here another list containing the odd numbers, and those are the numbers that are in A, but that are not even. So we can write just that. We can say odd equal x for x in A if x not in even. This almost reads like plain English. Finally, because this x varies across all the elements of the list, we can actually use that to operate on the elements of this list. So we're not obliged to take x as it is for x in A if x satisfies some condition. But we can, for instance, build the list where we start from another list and we apply a particular operation to each of its elements. This is an example. So here I've got the codons for leucine, and I want to replace U with T in all of them. So what I do is I create a list comprehension where for x that varies in that list, I take the value of x and I replace in it U by T. If I do that, you see this replace operation is applied to each and every element of the new list.